Good afternoon, distinguished guests and colleagues from China and Malaysia. My name is Han Ce from Hebei Penghu Information Technology. It's a pleasure to share lessons from China's smart city journey and explore what they may mean for the next stage of development in Malaysia. The previous presentation has just outlined Malaysia's directions towards safer, greener, and more integrated mobility. I would like to continue from the point and ask how mobility can become the entry point to a wider city capability. My topic today is smart cities in balance. Balance means choosing an appropriate scale, setting clear boundaries for technology, managing the pace of investment, and keeping public services humane. From a Chinese technology company's perspective, the question is whether a local team can use a system every day and improve it over time. This is why lightweight implementation has become central to our work. Reuse what the city already has, connect it through software, and add hardware only where evidence shows a real gap. Why have we reached this wheel? China's decade of digital construction gave us strong integration and delivery capabilities. It also exposed a recurring gap between the system's launch and its daily use. Chinese technology companies learned to connect complex systems, integrate different devices, process large volumes of data, and deliver projects and demanding operating environments. Those capabilities matter. The lessons from what remain difficult matters just as much. Some projects collected large amounts of data, while field coordination still depended on the telephone calls. Some cities installed many devices, yet each department managed its own system and created new data silos. Some advanced platforms gradually lost activity because data updates, operating budgets, or coordination mechanisms were missing. These experiences led us a simple conclusion. The value of a smart city should be measured by the problem it solved. Cameras, sensors, and control room screens show the scale of construction. Real capability appears when a city detects problem earlier, assigns responsibility, acts in time, and learns from the result. China's smart city journey can be seen as four overlapping steps. The first step was digitization. Cities created basic records, databases, and departmental applications. The second step was connection. Platforms began to link transport, public safety, municipal services, and emergency response and citizen services. The third step introduces data analysis and intelligent decision support, video analytics, forecasting, digital twins, and city brain projects help cities detect patterns and respond faster. The fourth step is continuous operation. Cities are building the organizational capacity to keep this system useful. These steps overlap. A city may have advanced in AI in one domain and incomplete assets records in another. The important change is the unit of value. A successful project is increasingly judged as the lasting city capability beyond the completion of a system. So consider a flooded city road. Traffic teams see road access. Drainage teams see pipes and pumps. Public transport and emergency teams see roads and response risks. A useful city system detects the water early, estimates the affected area, and sends the same event to the right teams. It provides timely travel information and records the cause and the result after the site is cleared. Data can come from existing cameras, weather services, water level devices, buses, inspectors, and residents. AI detects abnormal conditions. A shared event model, workflow software, and mobile evidence connect the response. When these elements form one complete process, transport data becomes city action. The city gains a common operating picture without asking every department to abandon its own professional system. Each team sees the information it needs, while the event, responsibility, response, and evidence remain connected. This examine also shows the boundary of technology. AI can help detection, classification, and prediction. Critical control still needs deterministic rules, local safeguards, and authorized people. Three conditions help us process work over time. The first is lightweight sensing. Start with an inventory of existing cameras, signals, buses, parking fees, mobile teams, and citizen reports. The remaining information gaps determine where new sensing is justified. Dedicated devices remain essential for safety-critical gaps. Each one needs a defined problem, a known data user, and a practical maintenance plan. This keeps investment precise. It also makes future maintenance visible before equipment is purchased. The second condition is open connection. Cities need different companies, devices, and departments to work together under clear security rules. Open interfaces, shared data models, and transparent access control reduce integration cost. They also leave space for Malaysian companies, universities, and innovation teams to participate. Open connections also protects future choice. A city can improve one component, introduce a new supplier, or add a local application without rebuilding the whole system. The third condition is continuous operation. Every smart city scenario needs an owner, a response time, and a way to confirm the result. The measures can be practical. Was the event detected earlier? Was the handover smooth? How long did it take to restore the road? Did repeat complaints fall? Did travelers receive information in time? The operating loop has 5 links: detect, interpret, assign, act, and learn. The difficult part is keeping every link connected. An alert without an owner adds noise. A work order without field evidence weakens learning. Inconsistent names for road, vehicles, incidents, or work order slow cross-agency response. A lightweight platform should focus on a small set of shared city objects and events. They need consistent identities, locations, status, and history. This shared language allows data from different suppliers and agencies to describe the same situation. It also makes responsibilities and response history earlier to audit. This is enough to support many valuable decisions. A highly detailed digital copy of the entire city can wait till a specific planning or engineering problem requires it. So Malaysia already has a strong foundation for this work. In Malaysian ITS Roadmap 2030, the city initiatives shown here provide clear directions. From China's experience, the next practical question is how these goals enter daily city operations. A useful starting point is to turn existing transport data into events and can be assigned, resolved, measured, and improved. The operating logic can adapt the metropolitan regions, faster-growing cities, and small municipalities. The next presentation will examine Malaysia's mobility landscape and research challenges in greater depth. I will stay with the implementation question. How can a city create an operating capability that local teams can sustain? Mobility can be the entry point for wider city collaboration. Begin with one area where the problem is operating responsibilities are clear. The same operating methods can then extend from flood roads and to damaged assets, waste collections, major events, and integrated public transport. A damaged road asset can connect traffic operations with municipal maintenance. Integrated transport data can support journey planning, first and last mile services, ticketing, and mobility as a service. Success should be measured across several dimensions. Travel may become more reliable, roads may become safer, public transport may become easier to use, and energy use and emissions may fall. Accessibility also matters. People without the last smartphone or digital payment tools should still be able to use the service. A practical starting method is concise. Start with an inventory, choose one or two scenarios, stabilities, the complete operation loop, and scale only what produces clear evidence. The pace should follow each city's baseline, risks, and organizational capacity. Chinese technology companies can contribute mature software components, data integration, artificial intelligence models, system engineering, and experience with complex delivery. Malaysian government agencies, technology companies, universities, and operators bring knowledge of law, public responsibility, local culture, and daily operations. The work should be co-designed from the beginning. Interfaces should remain open. Data responsibilities should be clear. Documentation, training, and operating knowledge should stay with local teams. Chinese capabilities can then be recombined under Malaysian conditions, while the city retains control of its data, rules, and development pace. The division of rules support shared delivery and local continuity. The, the project can begin with a focused operating problem, prove its value, and expand through evidence instead of committing the city to a large fixed blueprint at the start. So technology can help a city see earlier, assess more accurately, and act faster. Lightweight implementation allows these capabilities to enter daily operations with lower maintenance pressure. Open collaboration allows the city to keep choosing, adapting, and improving. Malaysia can combine China's learning curve with its own institutions, finance, and urban conditions to create a lighter, more open, and more sustainable path. The result should be visible in daily services, problems found earlier, teams working together, and residents receiving a more reliable response. So let technology become a city capability while the city keeps control of its own pace. Thank you.